Okay, guys. So, one of the important things about financial maths is that sometimes you're given an opportunity to borrow money and they don't tell you what the interest rate is going to be. So, when you borrow money off some people, they might say, okay, fine. You can have, for example, some people talk about this like on like furniture, where they talk about a deposit and then monthly installments. But they don't tell you how much better off you're going to be. Also, some people might do this with, say, mobile phone plans where they give you on a contract and you pay for it over time. So one of the things that these are all examples of what's called time payment agreements. Sometimes they might be called personal loans or hire purchase. There's lots of different names for them. So what we're going to do in this chapter is we're going to look at these different types of time payment agreements and calculate the interest rates on them so that we have some idea of just how much the other people are making off borrowing money off us. All right. So my first image is here. This is called the flat rate of interest. All right. What we have here is a formula RF, which is called the flat rate, is equal to 100 times I divided by the principal times the time. All right. And what that means is that if, for example, I have, I'm buying a new computer. All right. I'm buying a new computer, but I don't have the $3,000 that they want right now. But they will offer it to me on credit, where I put down a deposit and then I give them monthly installments until it's all paid off. So in this example, I'm going to bring up my damn whiteboard. So in this case, I could, for example, so if I pay a deposit of $500. And then I might pay so I pay a deposit of $500. I make 12 of $250 monthly. So it's a $3,000 computer. So it's a $3,000 computer. I pay $500 now, and then for 12 months, every month I send them $250. By the end of it all, how much money have I actually paid? What is the rate of interest that I have been giving that money at? So we don't know the interest rate, but we know how much interest we will pay. So if I go through with this deal, how much money am I actually handing over to this company to buy or get this computer on credit? All right, so I've put $500 down already. So how much am I actually borrowing off these people? I've given them $500 already. So how much money am I actually borrowing off them? 2,500. All right. So I'm borrowing 2,500. Now, if I pay 12 monthly payments of $250, how much money am I actually giving him in the end? Yep. So 12 times 250 equals $3,000. So now what I've done is I have worked out, so how much interest am I actually paying on this whole thing? I borrowed $2,500. I am paying them back $3,000. So my interest is $500. So I have the interest. So 3,000 minus 2,500 is 500. So now we move to actually applying our formula. RF is equal to 100 times I, which is the interest paid, divided by the principal times the time. So 12 months, how many years is that? That's 1 year. So the principal, so I borrowed, so it's 100 times 500, because I borrowed 500, I ended up paying them back $500 in interest. I borrowed 2,500 to begin with, and it was over a year. So, what's my answer? What is my flat rate of interest? 100 times 500 divided by 2,500 times 1. So the times 1 can go away. We don't need that. We can cross off a 0 here and a 0 here, to cross off a 0 here and a 0 here. So we're left with 500 over 25, and that is I'll take 20. So that means that they are loaning me this money to pay for this computer at 20% interest. Does that deal make sense? You've walked into a shop on January 1st and said, I want to buy a computer, but I've only got $500. And they're like, okay, cool. You give us $500 now, and then every month until the end of the year, you'll give us $250 more. And then at the end of that year, you'll own the computer, we'll have our money, you can leave with it right now. So that means that after all is said and done, you've given them $500 more than what that computer is actually worth. But you get to have it now. Now. You don't have to wait a year to save up that money. You can have it right now. And you won't even notice that you're paying interest yet. All right. This is why we do these calculations, so that when we do work out the flat rate of interest, so a down payment is also called a deposit. All right. So you put $500 down, that's your deposit, that's your down payment. That's proof that you can assemble some sort of money. Should have just looked on eBay. Fair enough. All right. So under this agreement, you can see that I have been paying through the nose for this computer. All right. So there's your flat rate of interest, which is looking at it over the course of the whole thing. But if we think about what the effective interest rate is, we think about it in terms of how do we split that money into paying off the original deposit and then just paying off the interest. So we have a particular calculation regarding our flat rate of interest. And now we have a new formula to go with the one up the top there. So I'm just going to turn that one on. Let's put that one up top. The effective interest rate is calculated as a percent of the average amount owed. So I can reframe my thinking by thinking about how much of my actual payments is going towards interest and how much of it is going towards me paying off my original loan. So if I take my situation again and I use the formula that's up here, I have what is called an effective rate of interest, which is equal to RF times 2n over n plus 1, where RF is this number here, and n is the number of payments that I have made. So, if I'm making payments every month for a year, how many payments will I have made? 12. So in this case, I'm going to go, the effective rate of interest is equal to the flat rate of 20 multiplied by 2 times 12 divided by 12 plus 1. So that means it's going to be equal to 20 times 24 over 13. And what is 20 times 24 over 13? So 36.92. So the RE is approximately 36.92. And what that's telling me is that my effective rate of interest on any particular payment that I make, 36% of that payment is actually going towards paying off just my interest. That makes it look even worse. That's even worse of it. That's looking even more and more worse of a deal. It's a very Trump sort of deal. What do you notice about my RE and my RF numbers? So RE was 36.92, but RF was 20. What are they approximately in relation to each other? And yes, that is exactly a good observation. They're making mondo money out of it. And the catch is that if someone doesn't make a payment, they get to take the thing back and keep all the money they already have. It is a massive, massive money maker, and people fall for it because they're impatient. They want it now. All right. So RE and RF, if RF was 20%. What is that? What is that RE by comparison to RF? What is it approximately? This 36.92, what is it in relation to 20%? How much bigger is it? Think of it as a multiple. I'm thinking of it as a multiple as opposed to just a raw addition. Approximately. What's it close to? Almost double. All right, and that is actually the last little thing I need to teach you guys today. If you need to estimate your effective interest rate on a time purchase agreement, you can approximate it by simply doubling the flat rate. All right. So, someone has just asked me to do another example of RE. That's cool. I can do that. So, if you are ever in a situation where you're under time pressure and you need to calculate the effective interest rate, just double the flat rate and you're pretty darn close. All right, because n over n plus 1 tends towards being equal to 1. Tends to. The larger the numbers, the closer and closer it gets. So if we're talking about an interest rate over the course of 100 years, well, that's 200 divided by 100 plus 1. That's like 1.99999. All right? It tends towards 2. All right, so one more example using RE. All right, so let's, give me a sec here. I'm just going to pull. All right. So, equipment which normally costs $750 can be bought through a hire purchase agreement with a $200 deposit and $26.40 a month for 30 months. Calculate the amount of interest being charged, the flat rate of interest per annum, so per annum means per year, and the effective rate of interest per annum. Per annum, again, per year. So, first things first, we need to work out how much interest is actually being charged. So, cost $750, but you've paid $200 deposit. So there's your deposit. So how much is left over? What's left over, guys? Yep, 550. All right, and because we need T for time in terms of years, we need to know how many years this is going for. Well, 30 is equal to 2.5 years. So now, we've worked out how much money is being borrowed. We've worked out how long it's being for, but how much money is being repaid? So what we need now is we need 20... is we need to work out 26.4 times 30. Can someone please do 26.4 times 30 for me? $792. Anybody else disagree with that? I think it's perfectly fine. $792. So, How much interest is being charged? Well, this is how much money we've borrowed. This is how much we have ended up repaying. 792 minus 550 is equal to $242. So, this is P, this is T, this is I. So, from here, what do we got? So, our flat rate of interest is equal to 100 times I over P times T. So that's 100 times 242 divided by the principal, which was 550 times 2.5. So you're going to need your calculator for this one because it just can't just simply cancel things down. Not nice and neatly anyway. Oh, here's Mr. Kaz to help us out. $100 times 242 divided by 550 times 2.5. Make sure we've got some brackets in here so that they doesn't try and BODMAS us to death. 17.6. All right. So the answer is, what is the flat rate of interest per annum? 17.6. So now that we have that, we can move on to the next bit. So I'll just turn the calculator off for a sec. So now that we have that, we can now move towards working out RE, which is what was requested. So remember that RE is equal to RF times 2n over n plus 1. So in this case, n is the number of payments we made. How many payments did we actually make? How many months was it for? 30. Thank you. So that means RE is going to be equal to 17.6 times 2 times 30 divided by 30 plus 1. And for the sake of argument, we can also say RE is approximately equal to 2 times RF, just so that we can do some calculations here just to help us out. So we do 17.6 times 2 times 30 divided by 30 plus 1. And it comes out as about 34.06. And using the estimation thing of 2 times 17.6, 2 times 17.6 is 35.2. So there it is approximately, and there it is in reality. hence why it's only known as an approximation. All right. So the work that needs to be completed for this period is part 1 of 4E. All right, so it's 4E-1. So we'll do parts 2 and part 3 next class. But for now, we're just worrying about these 3 things.